Welcome to this channel, and in this video we'll do speed of efflux Toricelli law. So what Toricelli law states that it states that the efflux, what is efflux? The fluid outflow. This you can see a tank here and there is an opening in this tank. So this efflux, the fluid outflow through this opening, Toricelli says that it will equal to the for an open tank. Just remember this, for an we will consider a case in which we'll take a closed tank, but later on we'll switch the condition for the open tank, and in that case the fluid speed of this efflux will be equal to the of a body in free fall, the velocity of a body in a free fall. That will look further. Okay, first we'll take the condition for an open closed tank. Okay, then when switch the condition, but you can plug in the condition for an open tank. Two things you have to understand first, but knowledge principle you should remember, understand that we have done in previous video, and also principle of continuity. V1 A1 is equal to V2 A2 for two cross section, different cross section of a fluid flowing through a pipe. The velocity multiplied at the velocity at the first cross section area multiplied by the area at the first cross section is equal to the velocity of the second at the velocity of the second cross section area multiplied by the area of cross section at that cross section. Okay, that you should remember, understand. And for knowledge principle, the total energy, pressure energy plus kinetic energy plus per unit volume plus potential per unit volume is a constant for an incompressible and a steady flow. Okay, now so let's understand this in detail. Yes, the word efflux means fluid outflow. Toricelli discovered that the speed of efflux from an open tank is given by a formula identical to that of a freely falling body that I have made you understand right now. Okay, consider a tank containing a liquid of density rho with a small hole in its side at a y height y1. So at y1 height there is a hole here. Okay, y1 height you can see a hole. Okay, the area of this region is, this hole is a1. Okay, and the velocity at this region is v1. Okay, now we'll consider area at the topmost point, which is at height y2 from the ground. Okay, from the bottom left it is at y2. Obviously the difference between this y2 and y1 is h. Again, the pressure, suppose the pressure at this height is p, p2 pressure is p, the area here is a2. Okay, so we'll just apply the principle of continuity, that is the velocity at this point p1, okay, rather p2 v2 a2 will be equal to v1 a1. Okay, for now we can consider this to be, the area is larger here, the velocity is almost zero. Okay, so will be no velocity here, and so v2 will be 0. Okay, let's understand it further. Then okay, that this is the thing what I told you. Okay, if the cross section area of the tank is much larger than the hole, then we may take the fluid to be approximately at rest at the top. V2 will be 0. Now we will apply the Bernoulli's principle. Okay, now applying the Bernoulli's principle at V1 and 2 point. Okay, this region and this area and A1 and 1 and 2. Okay, so what will be there? The pressure, okay, the sum of pressure plus pressure energy plus kinetic energy plus potential energy will be equal to pressure energy at this point, kinetic energy per unit at this point, and potential energy at this point. Here, as I told you, velocity you have taken assumed to be 0, so there will be no kinetic energy, there will only be potential energy and pressure energy. So at this second level, second stage, it will be only pressure energy per unit volume and kinetic potential energy per unit volume, that is mgy2 divided by volume, that will be rho g y2. Okay. For this reason, this part, one reason, there will be velocity will be there v1, so there will be kinetic energy, there will be potential energy, there will be pressure energy. So pressure energy is pa here, the atmospheric pressure is acting here. Okay, and there is the kinetic energy is half rho v1 square, kinetic energy per unit volume again remember, and the potential energy is rho g y1. And we now can shift this side, the we can take pressure on both p here. Okay, pa this side, p minus, it will be equal to p minus pa, and this to this side. Okay, so rho g will be common, so it what will get y1 minus y2. And you can see from the diagram, y1 minus y2, y1 is this part and y2 is this part, so the difference is h. So what we'll get, p1, yeah, so we will obtain p minus pa is equal to rho g, y2 minus y1 is h, plus half rho v1 square. We are concerned with the velocity, we have to take in the velocity, we will shift that to the other side. So what we'll get yes, 2gh plus, and p1 minus p2 is equal to half rho v square. We now shift it to this side. Okay, so 2 will be shifted to, it is not it was rho gh. Okay, now we'll shift the rho, will cancel out. Okay, we'll divide it by, we'll just cross multiply, 2 will be shifted to this side, it will be 2 here. Okay, and 2 will be here also. Okay, and rho, we will divide the whole equation by rho, so there will rho will cancel out, rho will be here, and it will cancel out here, and we'll take the square root. We'll obtain this expression for the velocity of a flux, root 2gh plus 2p minus pa upon rho. Okay, okay, so the condition is when p is very greater than pa and 2gh may be ignored, the speed of the flux determined by the container pressure. Okay, if the pressure inside the tank, about the tank at the highest region was it's greater than atmospheric pressure, okay, then this part can be ignored because this is very small. When will this condition happen? In rocket propulsion. In rocket, the pressure inside is very high and there is no atmospheric pressure. In that condition, what will obtain, this can be ignored, so we'll only obtain v1 is equal to root 2 p minus pa upon rho. Okay, and on the other hand, on the earth, okay, and for an open tank, what will happen, the atmospheric pressure and this pressure will be same at the, this part will be pa. Okay, this will be pa also, so it will be cancel out. So what only remains is v1 is equal to root 2 gh, which is the speed of a freely falling object, and this is the Toricelli's law. I hope you understand this Toricelli law clearly. Okay, give your feedback in the comment section, like this video if you understood this video, and subscribe to this channel. Thanks for watching.